smart students. In this type of questions, if we have a displacement and we need the acceleration, we can find the velocity and then find the acceleration. How? By using this important rule. What is the relationship between S, displacement S, and velocity V and acceleration A? From S to V, we can find the velocity V by using this rule. The velocity equals derivative or differentiation of the displacement S with respect to time t. V equals ds over dt. And from velocity to acceleration, acceleration equals dv, derivative of velocity with respect to time t. Okay? And we know that the differentiation is very, very easy. If we have y equals a t to the power of n, that means dy over dt equals a times n. Find the multiplication of the coefficient times the power. Okay, a times n, an. And write t, your variable, but your new power is n minus 1. Subtract 1 from your power. This is very, very important rule of the differentiation. And if we have at constant multiplied by t, derivative of this constant equals a, just a, without t. And if we have constant, just constant without t, the derivative of this constant equals 0. Okay? Now, let's go to our function s. S equals 2t cubed. That means the velocity equals ds over dt equals, first term contains 2 as a coefficient and 3 as a power of t. We can multiply this coefficient 2 times your power 3. Okay, 2 times 3. 2 multiplied by 3. 2 times 3 equals 6. 6, okay? 6. T to the power of, what is your new power? Is 2. Subtract 1 from your power. Your power is 3. Subtract 1, we get 2. 6t to the power of 2 minus, what is your coefficient? Is negative 5 and your power is 2. Find the multiplication. Negative 5 times 2 is negative 10. Negative 10 t to the power of 1. Subtract 1 from your power. 2 minus 1 is 1. Don't write 1. We get negative 10t. If we have any number as a coefficient of t, write this coefficient without t. 6, just 6. Derivative of 6t is 6. And derivative of this constant, derivative of constant equals 0. Don't write this constant. Okay, this is the first derivative. This is the velocity. Now we need the acceleration. We know that the acceleration is the derivative of the velocity, differentiation of the velocity with respect to t. Find derivative of this function again. We have 2 as a power and 6 as a coefficient. Find the multiplication of these numbers. 2 times 6 is equal to 12. t to the power of 1 subtract 2 minus 1 is 1. 12t to the power of 1 minus 10, just 10 without t. If we have any coefficient times t, write this coefficient without t, minus 10. And this constant, derivative of this constant equals 0. Now this is your second derivative. This is acceleration. The acceleration is given in this exam. The acceleration is 5. Find the value of t. This is 5. Transfer 10 to the other side. We get 12t equals 5 plus 10. 5 plus 10 equals 15. Divided by 12. 12 both sides. We get t equals 15 over 12 or 5 over 4. Simplify 5 over 4 or 1.25. This is the value of t, 1.25. But your important idea, if you have the displacement, the velocity equals derivative of displacement with respect to time, and the acceleration is the derivative or differentiation of velocity with respect to time. A equals dv over dt and v equals ds over dt. And you can solve any problem like this problem by using these rules. V equals ds over dt and acceleration A equals dv over dt. Thank you very much.